Perfect. Hi all, welcome to the Multimodal Weekly webinar series hosted by the team of 12 Labs. This is a weekly virtual webinar series that we're meeting on a weekly basis every Friday at 1:30 p.m. Pacific time. Here's some of the topics that we tend to cover each Friday: news, research in multimodal AI and vision models, innovative multimodal applications, different verticals, different projects in video multimodal that our community members like to share, and sometimes tutorial and guides from our internal team members about the 12 platform and API. Here is the list of some of the recent speakers that we have on our series, a wide range of diverse background from startup founder to open source contributor to hackers to multimodal researchers. For the webinars today, which is the number 26, we have 3 speakers. The first one is Chris Kennedy, currently working on the Groovy AI Bot. They will talk about the project Groovy AI, making AI pipelines easier to build and operate with least amount of effort. And Chris actually a second-time speaker. Our recording first presentation was back in like June or May, right? And then I was very excited to see some of the progress that he's been making, over the past 5-6 months, because we've been posting a lot now on our Discord channel with some of this progress. The second speaker is Eugene Cheah, the CEO and co-founder of Recursal AI. He will give a talk about RWKV, which is I'd say a new architecture that is designed to replace transformer. And fun fact, actually, I know Eugene, since last year. He was actually one of my housemates in my previous co-living place in San Francisco. So we connect, and our path kind of cross again. And now he's working on a AI startup that's trying to improve the state-of-the-art models. So very exciting to see how to hear more about the origin of that project and how it will evolve in the coming years. And then our final speaker is Kirk Marple, currently the founder and CEO of Unstruk Data. He's also active members of our Discord since the early days, with a strong background in video engineering and Unstruk Data. And he will give a talk on Multimodal RAG using Graphlit and GPT-4 Vision to enable insights. And this is based on a recent blog post that he published on the Graphlit blog that I came across with, and I thought that some of the insights very relevant to our community members. So with that, quick logistic note about the webinars: feel free to send your question in Zoom chat as the speaker is talking, and they can circle back to them once they finish with the presentation. And then we also have a short Q&A session after the speaker finish for any real-time question that you have. So with that quick logistical note out of the way, I'd love to invite Chris on stage, and you can start sharing your screen and go ahead with your presentation.
Okay, great. Well, it says that you need to enable screen sharing.
Okay, now I think you should be able to.
Perfect. I'm Chris Kennedy. I'm here today to talk about my project, Groovy Life AI, under my spare time Groovy Organization, making AI pipelines easier to build and operate. And also this presentation, this QR code and link will be available there with the slides. So I have multiple dimensions of interest today, designing in a fast, efficient way, dealing with the current field of AI moving so fast, operating with minimal interruption to the system, operating without any loss, as little loss as possible as you're updating things, a disposable software mindset where you're building fast and dealing with lots of Python model code that might need special dependencies, running local models at near zero cost, trying to really do as much as you can without paying companies for experimentation, making knowledge consumption more into an art, and delivering news your way with AI, which I'll go into towards the end. So Groovy Life AI, the architecture diagram, basically I built a bunch of Python processes that talk through ZeroMQ, so they're seamlessly kind of speaking together, and you have like input of different sources, so you can have news, Twitch chat, you keep histories of that. You can have I have context injection with a vector database, doing RAG into the conversation like where you're feeding possibly multiple LLMs that could see each other's conversations. So you're going into an LLM and producing text out to multiple, like text to speech. Then you have text to image, text to music. I have prompt optimizers, basically putting this all together to play back. So that's basically the overview of how it works. Using ZeroMQ, which is allowing it to be like it's each part is together is one big program, but yet they're separated. Being able to publish to a broker and subscribe to the broker, which right now it's real basic, but ZeroMQ works so well. It's pretty much out of the box, just like you're doing this amazing networking that no other system seems to be able to do. Passing along messages, streaming segments of text in logical chunks, like a transport stream. So like MPEG-TS was kind of an inspiration for this, having multiple types of media aspects of a transcript flowing through, using a header format where you can like stuff in all JSON data you need and blobs of data, like binary data with it. So you can like pass around stuff real efficiently and store it and have it coalesce together, possibly distribute it out separately, where you're doing little tiny sausage like text chunks and you're putting them out there to multiple potential processors that take different latencies, and you're putting them all back together basically to play back. And also for things like I have to control puppet mouth speech movement, you need the audio of the speech, but not the produces music. So you separate that out. You can have Adobe Character Animator, NDI, send that to OBS on another system. Also, these can all be on separate systems. You could have an army of MacBooks running this. So each one, within two processors, you could run a whole lot of power with commodity systems, split it up. You avoid, downtime. You can have these self-heal. You're isolating it and splitting across. So it's really interesting. It's allowed me to move really fast and just building something that I built in TypeScript. It's like this has just been way beyond what I could do in TypeScript already in just a few weeks. So trying to do as much as you can as fast as possible with minimal downtime. The environment right now is so fast, things come out. You might throw away something, need to rebuild it overnight with a cool new model that comes out, or a way to do something. Replacing things in operation. You lose some simplicity. The documentation isn't great, but I'm trying to make it where each of these things are very easy to understand, and you can just look at it and you don't have to understand the complexity of an architecture other than these are little modules that fit together with the ZeroMQ protocol. Unit testing would be interesting to try to figure out in the future of these parts. It's somewhat hard at times to know if everything's going to work right when you change something, but it seems to work out really well. I've had a lot of nice experiences doing it this way. I'm running on a local M2 Ultra with that ARM, like LLM, Stable Diffusion, Music Gen from Facebook and text to speech. It's an upfront investment, but you have basically you're paying for your power, which is very low with the ARM. And it's running really fast. It's able to keep up with all of this. It's running like up to 70 tokens per second at times with that 8-bit model, 7B. So it's kind of, usually average is more 20 to 30 with everything running together. 2 images a minute, Stable Diffusion. You could spend hundreds of dollars a day for this, text to speech. And Mimic 3, which is very interesting. It works pretty well. It's all free. It has hundreds of voices actually, which is there's some pluses and minuses, but yeah, just being able to experiment and do something like this without spending money. So the concept of getting your news as art, dynamic disposable content where you pull it in your news feed, but you could like augment it. You can transform the hate stream into a love news stream if you're, like very sensitive to certain topics or just news in general. I've been listening to news lately with this in my Twitch channel that I hate news, but I have it tuned to AI. It talks all about the current AI news, so it's very cool. So turning that knowledge consumption into an entertainment in art, making it where that's your entertainment perhaps, or at least something that entertains you as you watch the news. You can slice and dice, augment current events with your documents, your wisdom, whatever you want to add into that, the current news stories. And distillation of information knowledge to your taste and liking. It's interesting, you hear so much about the fake news aspects of AI, but you could use that also for the benefit of people too. And so future directions would be like Ingescape from the ZeroMQ. It looks like it would make it where you can like just run functions across distributed, like where you no longer are just making connections, but you're like one big program, real IPC. That looks exciting to get into. It looks like it's built for this stuff. They're working a lot on it, it looks like. So it looks fun. 3D model control and audio video augmentation, other things. And I will go over here real quick and just a quick see if it works live. Right now on Twitch, it's running. And you might
Lindsay, I found there's breaking news from the financial community is something that could change the way we think about finance and the AI technology to Sigma H. Hunt has just crossed the $50 billion mark in assets under management using ML algorithms. As you all know, where Sigma is a leading quantitative investment firm with a wide range of expertise in various fields like mathematics, physics, and computer skills. And economics be using their expertise to promote the commercialization of cutting-edge AI
each one of those little
technologies in various industries, both domestically and internationally.
So basically it. Here's like on the code, it has source, it has details of all the parts and how to basically build one yourself, which on the references on this, I've got a bunch of links, and here's a bunch of to-do ideas, which I've got. It's just like a playground to experiment with in my spare time. But yeah, so here's the links where you can go to the GroovyLife.ai website. It has a lot of links to the stuff that the source code, Twitch channel, ZeroMQ stuff, all the different models, the main ones that seem really, really not. Basically it.
Right, awesome. Thanks for sharing, Chris. Very in-depth through your projects. I think out of curiosity from my own, like you try out different LLMs solution, right? I saw Llama 2 C++ there. I saw Zephyr from Hugging Face, if I'm correct. Can you maybe just give a high level experience of trying out these different open source solution and what is the best practices that you found for folks who want to implement themselves?
The Zephyr 7B has been the best. I've tried out multiple ones and the basic ones, and they work pretty well usually. There's a lot of fine-tuned ones, but a lot of times they'll have weird output at times, while the Zephyr has been really consistent and nice. And in the 7B is fine. I've tried to run the bigger ones and they work on the M2 Ultra. It's interesting, but to run this all together, you really just need a 7B. It seems like even the 8-bits are probably too much for this kind of application. It's like, especially for these chat things, they don't have to have that GPT-4 power. I can
tell. Yeah, Dorian, if you had a question, feel free to unmute or put on the chat. I think like one of the last slide you mentioned with the future idea is like having that multimodal communication, right? For the chatbot, how do you envision that looks like, and what sort of technologies you think people utilize to enable such a communication?
Oh, you mean to have them talk together, the different chatbots?
Yeah.
It's like interesting because you think of it like a room. You have people in a room, so each chatbot's like a person, and you have to kind of feed them each other's personalities even. So it's like you're not keeping context of just yourself and your system prompt, but you're going to have a system prompt that tells them the room you're in, there's participants, and just thinking about how that would change as people enter and leave, and real people versus other LLMs, and broadcasting the communication to each one. Seems like maybe even the LLMs could in the future change to fit that model, because right now we're thinking of this isolated one LLM creating a conversation of many people perhaps, or things like that, instead of each one being an individual.
Yeah. So in that demo of AI News, where did you ingest the data from to get real time.
Okay.
Yeah, display.
I've got
yep.
It's newsfeed from MediaStack, and I basically can pull news stories and just feed them in, and then they just bloom the whole output. And yeah, by topic or anything, search.
Yeah, and the personality of the Buddha, is that based? You can like configure whatever personality you want to choose for it.
Yeah, in Twitch chat, I've got it where there's pre-made ones and you can make your own, and you can control the system prompt and everything like that, like create custom ones. At that part I'm building out more. It's like, because it's just very simple right now, but that's in the framework I'm working in, has been really easy to just throw that in. Yeah.
I see. I guess one last question I have from my end is like, I'm not sure if the audience is like familiar, at least for me, I'm not sure I'm familiar with like, ZeroMQ and ingest, right? So those are some of the links that you put on your slide. Can you maybe just give a very layman term description of the system for the folks who are not familiar with them?
Yeah, you basically can connect and send TCP networking, multicast networking with zero latency, pretty much, like very low level. And it's very easy to use, just simple like Lego blocks. Like I want to make a subscription thing that other people can publish, push, pull models, all the different models. They just very complex stuff that's very easy to lay out quickly.
Gotcha.
It's also it's an FFmpeg is a protocol. You can like talk between FFmpegs with MPEG TS over ZeroMQ. I did this years ago myself at a job, and we ran the whole system using ZeroMQ to pass around MPEG TS itself across it. So it's very viable, very robust, and simple to stage up.
Okay. Awesome. Yeah, thanks for sharing those resources. It could be awesome. You could also like share some of the links on your last slide on the chat, so folks can peruse them on your own time.
Sounds good.
Yeah. And while Chris is doing that, Eugene, you want to start unmute and sharing the screen and start with your presentation?
Yeah, sure. Thanks for that. Sharing my screen. Okay, I'm going to post some links as well that's relevant to this. So, oops. Yeah. So hi, I'm Eugene. I'm from Recursal, but I'm here more like representing from RWKV group. I help manage the RWKV group together with the rest of the team. And RWKV is the world's first AI model that's under the Linux Foundation. It's open source, Apache 2 license. No funny clauses or terms and conditions, just a clean licensing. And its main difference is that it's a new architecture that is aiming to replace Transformer with 10 to 100x lower inference cost, making it highly energy efficient and it can run on nearly any hardware, which I'll cover more on that later. So in order for us to do all of this, right, RWKV takes a very different approach from traditional transformers. Right now, there is a sort of like a semi-small debate and an ongoing bet between high-profile researchers whether it's attention all you need. And there's also been research that's showing that attention is not the only mechanic that works in the transformers. And RWKV is on the side of no. Attention is not the core part of AI. And basically, from our point of view, actually any AI model, once scaled high enough, as long as you make it optimized enough, can work well with sufficient data. And the reason why we point this out is because the problem that we are trying to tackle that we fix is that transformers are slowly reaching their limit when it comes to context size. So I think we have friends here who just presented like being able to using their models with RAG and things like that. Context size limit is an actual bottleneck. And on the flip side also, the longer your chat history becomes and the bigger the context size is, the more expensive the computational cost increase because transformers just scale quadratically respectively. And this limits adoption both for AI agents use case and commercial use cases. It's also no secret that AI models are very GPU hungry to run that. And a lot of startups that is not OpenAI is struggling to get more than 10 GPUs from Amazon, for example, and limiting the deployment of AI at scale. RWKV is a new architecture that re-engineered the AI architecture from the ground up to be a linear transformer or attention-free transformer. And this allows us to scale based on the number of tokens linearly instead of quadratically. This translates to around 10x lower inference cost when you're at 2K context size or beyond that at 100K context size. And this benefit for lower inference cost, right, also translates to lower training cost. And more excitingly, right, the model is lightweight enough to run on CPU in real time, bypassing the GPU, and it's able to run on your laptop today effectively. We can run a 14B model on AWS Graviton, and we can easily run 3Bs to 7Bs on most modern hardware. And your mobile phone can easily run 3B to 1.5B today. But I think more importantly, despite it being a completely new architecture, it has no major performance compromise in quality or evals. It performs the same as Transformer. So the gotcha is with the same data set. And finally, once again, it's fully open source. Oops, I didn't know. Okay. And this reduce in computational cost, right, translate into real world impact. Like we are independently benchmarked as the world's greenest AI model in terms of joules per token in the 7B weight class. And once again, like when I say comparable results, if not, you don't even take my word for it. You can take Illustrator AI's, Microsoft, Stanford, who have actually published independent studies and papers comparing our RWKV PAL model against other open source models that are trained on the PAL. And the reason why I say the PAL is because you want to when trying to compare new architecture, you want to compare the same model with the same data set. Because data set is actually an equally important part of how a model performs. And we can only measure how an architecture differs when using the same data set. And in this regard, RWKV is competitive. So how did RWKV achieve all this and make it available within the open source space? I think if you remember the era before Transformers, we had RNN, and that approximately 6 to 8 years ago, RNN was the AI wave. Unfortunately, as we tried to build larger and larger RNNs, we realized it didn't scale well, and that subsequently led to the current era where Transformers came in and replaced RNN because they can scale up. The problem is not that RNN were bad. RNN is highly effective. Even Kapasi, one of the major leaders in AI, has an entire article dedicated to the unreasonable effectiveness of RNN. RNN is a very effective inference architecture, but it was a terrible training architecture. And that was because of the way LSTM worked. So if we take a step back, right, fundamentally, all AI models are input tokens to embeddings to being processed by the RNN state or by the transformer architecture, and then it gets layer norm and sample, and out comes a token. And in the case of RNN, this meant that for each token that came in, it goes through all the respective layers, and it gets processed again one after another. The bottleneck that prevented us from scaling at training is the red line you can see on the screen. In order to train the second token, you have to wait for the first token computation to finish. So what that meant is even if you have a 4090 H100, you are slowed down by the first few tokens. And this made it hard to scale any RNN to even a billion parameter, let alone the 100 billions that we are looking at GPT-4. And this is basically an illustration of the really slow training process of what RNN had to do. So what we did at RWKV is that as the whole world transitioned to Transformer and use attention, basically the creator of RWKV just asked and went to think differently, like, what if we re-engineered the whole thing for it to work? What if we remove this bottleneck? And that's basically what we did. We just basically cut that line. And this is where I would say RWKV has two major innovations. The first one is where we architected it to not be bottlenecked by the first tokens. So you can see this, respectively, it allows it to cascade in training. In actual reality, we do some batching in this cascading, so it doesn't look exactly like that. But the idea is that without that bottleneck that you saw previously, we can now train at scale, at transformer scale, without any compromise, allowing us to build the world's largest RNN model, which is RWKV today. The gotcha for this, and which brings me to the second innovation of what RWKV did, is that when you remove that line in LSTM, the whole model completely falls apart. LSTM was designed to have that data flow, and to remove that data flow, it just means the model will not converge. So what we did is we replaced the LSTM with QKV. We replaced the QKV and LSTM with what we call RWKV. And you can actually read more into this on the math side within the paper. We have published RWKV V4 paper, and this was co-written by Receptive AI team. To clarify one thing that some people get confused now, we are now in the process of building and training V5. There is no V5 paper. Because we are an open source code base and model first, we take the approach very differently. I know a lot of AI is now paper first, then model, then code. But because we are an active open source project, we get contributions from all around the world in public. We are code first, then model, then paper. Yeah. So you can see more on the V4 architecture within the RWKV paper, and we are expecting a V5 paper next year once all our models are ready. But what it essentially means is that when we replace the LSTM mechanic with what we call the time mix and the channel mix respectively. If you can see, the time mix here is where states are being passed forward and it's being handled accordingly. So you can view this as a replacement for LSTM, except that it uses dot matrix attention, similar to how QKV works, but applied on the state itself. Channel mix is used to further process those information, and you can view it as short-term memory and intelligence module. The reason why we use both is because during our iterative process research, we actually found that the model performs better when we have these two both together rather than one on its own. So what's the catch for this new architecture? Because despite it showing a lot of promise, is that we are only trained on less than 1 trillion tokens, less than 1/3 that of Llama 2, at 1/5 the parent count. Our biggest model is a 14B model. And that means we have to be realistic that this is not the best model out there. But for the use cases that it can run in, because due to the limited training or the limited parent count, it is one of the most efficient model out there. And that's something that we are actively working on to improve on, because once again, we are a completely open source project. Until recently, we never had a single VC money raised for building the models, and all our GPUs were basically based on donation time from Stability AI and Unstruk AI. And more recently, ever since we joined the Next Foundation, we are actually working in partnership with Lynn Foundation to get high performance supercompute clusters to actually scale our model even further. So yeah, that's the summary of RWKV. It's a new architecture that is aiming to replace Transformer, aiming to kill all the existing models that you're familiar with and replace them with something much more efficient, so efficient that you can run it on your phone. You can get more links from the wiki, or you can even do a chat demo respectively. And actually, like, to highlight like what we meant by efficient, right? Very recently, we worked together with A16Z AI Cloud, and we actually got RWKV running on a local MacBook, where you can see 120 agents running, chatting to each other, and it's barely eating the CPU. In fact, when we increased the scale to 120, the bottleneck was not the AI model. The bottleneck ended up being in the pathfinding of the game engine. So that was an interesting scenario where the AI model was no longer the bottleneck, and it just shows that at 1.5 and at 3B specifically, a chat model is highly useful for this kind of use cases. And I'm actually quite excited to hear, like, ever since this came out, a lot of people has actually considered and trying to explore using RWKV, especially our 3D model, to be implemented in games, because who wouldn't want a town of folks that respond realistically, like a real life character? So yeah, that's what we do at RWKV, making existing AI models way more efficient and truly open source.
Awesome. Thanks, Eugene. Actually, I'm curious. Do you mind giving like a live demo of the chatbot, the link to the chatbot that you shared?
I will need to switch laptop because this is my old laptop that I just use for presentation with the camera all set up.
Okay, no worries. No.
But
Yeah.
I can send the link to the project, no issue.
Yeah, I already put that one on the chat. So
yep.
I think another question that I have is that maybe can you emphasize more on the use cases of RWKV? So you mentioned on the slide that it might not be the best performing LLMs in the market, but for the use cases that it does, that is one of the most efficient one. Can you highlight more? What are those use cases you mentioned here? Gaming being one of them. What are the real world application can this architecture be utilized?
So being realistic, like the model right now performs at best closer to GPT-3 rather than 3.5. That's due to the training limit. However, like I think as highlighted previously here, you don't need a GPT-4 or even a 3.5 for all your use cases. So what we find among our Discord users, the most common use case is character and personality AI. This is in part due to how small and efficient it is. A lot of people love to fine tune it for their favorite fictional character and to chat with them. It's in particular in Japan and Thailand that forms a very large user base in this segment. Then subsequently it'll be translation, summarization, and code generation. These are the four major use cases that we are aware of literally startup running RWKV in production. Naturally, there's also other use cases in between, which people may fine tune specifically for. And we notice that actually a lot of people are using the 3B to 7B to fine tune for very specific models and use cases from there. But even the base model is actually more than suited for the four use cases that I highlighted. And we believe that like as we scale up our training to 3 trillion and to higher param count, like we will actually just catch up with transformers in all use cases respectively, because one interesting thing to note in the Illuter AI paper is that even Illuter AI pointed out that it seems like our model scales slightly better per param than transformer, but it's not conclusive because we haven't ramped up to the higher scale yet. And if that is true, right, that means at 40B and 70B, we would be ahead of other transformer architectures, assuming the same data set, which is always the biggest caveat because yeah, one of my other statements that I say every now and then is that we pay so much attention into architecture changes when data set actually forms a huge half of how a model performs. And I actually feel that the industry as a whole should actually spend more time and money and effort onto data set, sampling techniques, and to actually improve the AI model's performance. But that's another topic altogether.
Yeah, I see. And maybe yeah, just kind of curious to hear your general thought on this one. But since startups focus a lot of, and this webinar as well focus a lot on like multimodal AI system that can work with different modalities. One of the reasons transformer is very efficient is because it can it's modality agnostic, right? It can work with like text and audio and image and video. Have you thought about that for RWKV? What do you think about like the applicability of this architecture for, let's say, image or video?
Yeah, so definitely, so at the end of the day, likewise, this is just a model that's data in, data out, same as transformer. So yes, you can use it for audio and visual. We do have like so we do have another like sub project where people are doing image and audio recognition and also like music generation. We also do have a sub project where we got a working image generator. However, I think like within our current team, because we only like 12 or open source members at best, we kind of concluded that we are not pursuing image generation further. Mostly because Stable Diffusion is doing a very good job, and and it makes no sense for us to be putting all our resources to compete with them when we should be focusing more on the text model type of thing. And we do foresee like in the future like AI agents will be using this in a hybrid use case. Like even OpenAI right now, when you'll be chatting with the model, but it's actually leveraging on DALL-E, which is a separate art model altogether to generate an image. And we expect a similar thing to happen back and forth.
Yeah, I think.
But it does work. It's nightmare fuel, the image being generated.
Yeah. Yeah, I mean, I'm actually organizing like a hackathon related to like AI agent and multimodal in like 10 days. So, I think like it's super relevant to kind of see how, Asian research develop and what can be improved to help improve the experience of these like sub AI agent, how they can interact with each other. So it sounds like this can be like one of the major use cases of the RWKV architecture. I guess one final question from my end for you is that open source ethos, right, that you emphasized throughout the presentation. So yeah, can you tell more about like how did you engage with the open source community? How did you how did the open source project works? Like how did you like gather commits from around the world, like kind of facilitate that discussion, and also like the role of Recursal AI as the holding company for RWKV as well.
Yeah, so I think so this is the part where I'll do the clarification. So like so for RWKV, right, like I think one thing that's rather interesting, and research whether I can open up the paper. I mean that's like not presenting this in full, but the thing is like the RWKV global user base is dominantly China, Japan, India, Southeast Asia, Thailand also is a major group in there, and then followed by Europe. And actually, the smallest group is actually our North and South American segment. And this is mostly because like very early on, right? RWKV was one of the first AI models to go full multilingual. So we were the first model to literally say, you know what, let's don't care about evals, because let's don't care about the English eval, and let's just import every single Wikipedia text out there, every single language we can grab our hands on to get our model to work for every language out there. And since then, that's actually been one of our main drivers of growth in Discord, because like until Llama 2 came out, for a lot of communities, be it like in Indonesia or Thailand, we were the only model that supported their language. And that drove like the major growth for RWKV. And in the very same way also, like we were the number one open source model in Japan until Llama 2 came out. And that speaks to more towards our how we came together as a mixed group, multinational group, effectively, and all of us just wanted to support our own language rather than the architecture. Because yeah, I have a separate talk regarding our tokenizer, is that in essence, right, most AI models today are not even built for English and English only, and it's not built for like the rest of the world. And I don't even mean like character languages. Like for example, like Chinese characters are like 4 tokens or 5 tokens, but even like French word can be easily 4 tokens. And and yeah, and this is a problem that we view that is something that shouldn't be ignored, and that's why we work very actively in the multilingual space, and we
Yep.
champion this extremely heavily. Yeah, and like right now I'm actually, like as Jay said, I'm in the process of setting up a new company called Recursal. And how we intend to actually balance this out is that RWKV will still be under the Linux Foundation. It will be completely open source. And my new entity is actually just going to be very focused on setting up to be the best place to run and host and fine tune your models, your RWKV models. And we did this intentionally because a lot of us in our community actually came on board to build RWKV because we were very frustrated about OpenAI. In fact, we tend to call it closed AI internally, and that's why we are extremely committed to making sure that this model will stay open source. So that's why it's part under the Linux Foundation. At this point, even if I wanted to close source this code base, I can't. Linux Foundation holds the keys, not me. And this same things apply to the original creator, BlinkDL, and everyone else in the team. And that's how we are very committed into like building this AI model further, because the way we view it is that we want a personal AI for everyone, be it a teaching assistant, be it a companion, be it a friend, or being just something that is useful to have alongside you, learning with you, and for everyone, and not just for the US. It's everyone in this world, in any language. That's why very intentionally our key models are called the RWKV world model. It's for everyone in the world.
Awesome. Yeah, I think that's a very optimistic take, and excited to see more the American adoption, right, of RWKV in addition to like this user base right here. Yeah, and with that, I let Kirk start his screen for the final presentation. And if folks have any question for Eugene, feel free to put them in the chat. Yeah, Eugene, can you stop sharing the screen first so we can? Yep.
Stop sharing. Oh.
There you go.
Got it.
See that okay?
Yep, I see it.
Awesome. Well, I appreciate being invited. Definitely an interesting topic that we've been exploring with, the retrieval augmented generation pattern and the new multimodal models from OpenAI. And so what this is based on, I did a blog post. I'll kind of walk through slides at a high level, but the blog post is available with more detail. But who are we? Who am I? Founder of Unstruk Data. Been working with unstructured data, video data, especially for, a number of years. I was at Microsoft after grad school, and then started a video transcoding and media management company, and got a lot of experience seeing kind of how media archives are built for, folks like PBS and ESPN. And after selling that company, I got really interested in extracting knowledge from that same media. So instead of putting data onto or video onto Netflix, or even some of the stuff we were doing in the closed captioning for some of the like PBS, AI, we started to use some of the early AI models for image detection, like object detection, things like Azure Video Indexer and different things like that. But really, what we had built now is an unstructured data platform. So let me switch over to just this diagram from our website. And it's really all about, taking any kind of data. Documents, email, podcasts, video from YouTube. So really being media agnostic and creating a full data pipeline flow from ingestion. But then this middle layer is the really important part. So we index metadata, so kind of the technical metadata that might be like in EXIF tags or XMP data or Dublin Core in the media, but then also prepare it for use by AI. Because a lot of the models, you can't send an HEIC file from your iPhone directly to typically to most of the image models today. So we can do data prep and conversion automatically. And then sanitizing for PII is important, running large language models or different AI models for knowledge extraction. And then it really comes down to, creating the semantic layer, what we create an actual knowledge graph from that data. And then we present that in a GraphQL API. And it's for a variety of apps. That's what we're seeing. Kind of chatbots and agents are kind of the typical thing people talk about. But just integrating with other services and having things like a Google alert that can summarize data. And this is where it really gets interesting with the multimodal side. So I'll flip back over. So I was looking into when the GPT-4 Vision model came out, was kind of looking at, we have this RAG concept that people are familiar with. You have, a knowledge store. You've ingested some data, you've typically extracted text, you've chunked it, run embeddings on it, and you're then providing it to the prompt context to run a prompt completion. And I started thinking about, we already support images and audio and video and things like that, but for images, what information can we get out of it that can work with this RAG concept? So large multimodal models are just starting to come out now. And this is kind of an example of a preview of kind of what we can do with them. So the first step was, okay, I mean, playing around with, here's an image of, here's the image. Oh, let me go back to here. Yep. An image I actually took, I'll show it in a second, but I was in Chicago, living in Chicago, and a fire at a furniture store started across the street. And I have a bunch of images from then. And I started to think about, okay, as somebody saying, trying to evaluate this event from the insurance industry, a lot of times, I mean, you have to visually analyze that data. You might tag it, you might write a text description, and some of the basic models today can maybe give a caption. So it can give a small caption. It might be able to do object detection in a bounding box on an image. But I wanted to see, I mean, how much could the new GPT-4 Vision models do? So this was a description that I could generate. And some of the interesting things, I mean, you could see in the middle here, Chicago Fire Department. So it's actually doing OCR, I mean, text extraction, in addition to just finding the sort of context of the image. And this is what I found really compelling, is it's actually mixing kind of what was capable before, maybe with 3 different models, all into one kind of promptable form. And here's an example of actually the prompt that I used. And so we're using an XML structure for providing guidance and instruction to the OpenAI models. This is kind of our a bit of a secret sauce that we use that works across Anthropic and the OpenAI models. And then kind of asking for JSON at the end. Function calling can work for this as well. But this middle instruction part is the interesting part. So we're actually combining text extraction with descriptions, with labeling, all in one simple prompt. And so basically what is happening is we get back the raw, I mean, Chicago Fire Department text or anything that might be a sign on a building, in addition to this longer text description and labels, which we can then inject into our knowledge graph as entities. And so the way this works in Graphlit, so it's a workflow-based approach where you can say, okay, I have data coming in, I assign a workflow which says, how do I process through the different stages? Ingestion, preparation, entity extraction, and enrichment. And here we've basically said, okay, use OpenAI image, use their low detail mode, have a confidence threshold that basically says, I mean, if you see things that are low confidence, ignore them, and extract labels. And so we have a GraphQL API. This is I created a workflow, and then I have to get the data from somewhere. And so we have this feed concept that you can point at RSS, you can point it at Notion and whatever. This was from Azure Blob Storage. And I assigned the workflow ID to that, so it'll use that as context for processing. And so this was the image I used it on. And we can see that it actually extracted the Chicago Fire Department text. One of the things from my experience, I'd worked in the drone imaging space for a while, and identifying text, especially like vertical text and sort of things on an angle, was really difficult. I mean, none of the existing models, like the kind of standard ones from Azure and AWS, could do this reliably. So I was actually kind of amazed that, I mean, it actually responded with that. But it actually found some really interesting things. So the police vehicle down here, the ability that they were on top of a building. There's a lot of detail actually just in this one image. And I gave it about a dozen images. And then it becomes, okay, well, what can you do with that data? So now we've extracted this base of knowledge, textual descriptions, labels, and things. And we want to now I'm actually using the new GPT-4 Turbo 128K model and saying, okay, I want to now do Q&A over that. So like almost like a chatbot experience. So we have a thing called a specification, which is kind of your preset for the model. You can see on the right how we configure that. And decided, okay, let's start with, tell me about the fire from what you saw in these images. And so we're prompting a conversation. This is a lot like the new OpenAI Assistance API, but we can do it in a model agnostic way and across a lot of different data types. And it was pretty interesting. I mean, it said a fire is actively burning on or near the top of a building with a brick facade. So it actually, I mean, really saw and had a lot of context. It knew it was a multi-story building. It knew there was a fire truck ladder. It knew the Chicago Fire Department was there. And it just described how it was a severe and dangerous situation. And so what I thought about is that, okay, as an insurance adjuster, and we dealt with insurance companies in the drone imagery space for a while. And I thought, okay, I mean, can you just tell it to act like an insurance adjuster and rate the severity? And surprisingly, it did a good job at it. And so it said severity of the fire, 8 out of 10. It recognized that there were intense flames and smoke and structural damage because it saw the building. But the other cool thing is, because of the metadata we had provided to it, it knew the date of the fire because of when the image was taken. It inferred the location of the fire, obviously Chicago, from the Chicago Fire Department. And you can see, I mean, I could go on and on with asking more questions, asking it to structure data. And the other concept is you can do this not on images just in a silo. If they have handwritten notes, if they have audio notes, you can actually combine all that data. And that's where multimodal becomes interesting. We've done a lot of work with audio, transcripts, and documents, but now we can add images into this mix. And we had done some work with, say, like site inspection at an oil plant, and the person we talked to would go around every day taking images of damage, and he'd write notes, and he could take little voice recordings of things he saw. And now you can see, I mean, we had done some work previously with just the text part of this, but now we can combine all these things together. And so one of the things we're working on is what we call kind of content publishing. So you could now automatically generate reports or generate, Slack notifications of, here's my daily summary of what I did today. And it just automatically generates it, not from the text and audio that people are familiar with, but from this robust image data as well. So yeah, kind of went through that quickly, but I mean, the blog post is here. I could share out the link. I'll share this in the Slack or in the chat. But yeah, happy for any questions.
It's great. Very cool insight from that project. And so the role of Graphlit in this context is to facilitate the ingestion of the image, right? So that GPT-4V can read that image, and then you prompt them.
Yeah, so we do this whole flow. So literally by the feed and the workflow, when I just ran those two commands, or really the feed command, it was fully automated. And so that basically pulled in all the images, the workflow tells it what to do, and it runs for a minute or so. And at the end of that time, you basically have this knowledge graph, this knowledge store of all this data. And that's then when you can just start leveraging it. I mean, chatbot conversation is the obvious thing, but it's really all the repurposing and publishing of in other formats that gets really interesting as well.
Yeah. I think, leveraging like all these different sources, especially in the enterprise context, can be very valuable for folks who want to they have like these different assets lying in different systems. And so it sounds like your API facilitate the connectedness of these different systems and kind of source it to the LLMs of choice, so that the LLMs can be prominent and make sense based on the data provided.
And that's the thing. I mean, it's really a multimodal and a model agnostic world that we're moving to. I mean, I think there's so many great open source models, like the last speaker, and just, be able to plug those in to these different workflows in different situations is where things get really interesting. And so, I think even video, once we can get more rate limits on the model, I want to do some testing with basically doing image grabs, for longer format video and see how it works like that. I've seen some demos of it, but we could do that in our system as well. So I think, there's just so much capability that I think it's just scratching the surface right now.
Yeah, for sure. I think multimodal RAG, this concept has become more and more popular. We have at least like 2 speakers in the past who like touch basically on this team, obviously different projects and different contexts, but it sounds like the common theme is like, given data of different modalities out there, now we have a model that can, process them concurrently and also have like infrastructure that are able to like facilitate the the preparation, ingestion, and pipeline. I guess that's the right word, pipeline of these modalities to merge them together. So yeah, super excited to see more of those going now. And
a lot of it is that canonicalization of the data, because you have to be able to provide it to the prompt. I mean, the prompts are still pretty simple. I mean, it's just text. But I mean, a lot of what we do is try and canonicalize things so that they can be merged together. And I think that's where it gets super interesting.
Awesome. Well, thanks, Kirk. I think we're at the top of the hour now, and it was a really good presentation. If folks want to connect with the speakers, I think I put all the details in the chat, so you can check out the projects, their demos, as well as their presentation. And I think that's about it for the webinars today. Thanks everyone again for signing up and coming. Thanks to the speaker for preparing the materials. And for those of you in the US, I hope you have a great Thanksgiving holiday coming up. Enjoy the rest of your weekend. Bye-bye.